Inventories. They're a key part of most item-based games and in almost every single genre, and you've probably wondered how you would go about adding one to your game. Well, today, let's create an inventory with the ability to pick up, drag and drop, split and stack, and drop items. So the first thing we need to do is to set up our inventory menu, and to do that we need to create a canvas to act as our player UI. On the camera of our example scene here, let's add a new canvas and rename it to player UI. Let's also make sure that when we add our canvas, an event system is added to our scene, because we will be using events to create our drag and drop system later and they will not work without this in your scene. Next, let's add an image to our game to use as a backdrop for our inventory menu, and to do that let's create a folder in our assets folder called UI, and let's import an image to use as a backdrop. By the way, if you would like to use any of the images used in this tutorial, there is a link down below to download them. Now, let's set this image as a sprite, and we want to set up the slicing borders for our image to have a clean resizing of the image, which is in the sprite editor, but this is grayed out because we need to download the 2D sprite package from the package manager. Let's open the package manager and search for the 2D sprite package and download it to our project. Now that we have the package, we can now access the sprite editor. Let's go back to our image and click on the sprite editor, and in there we are going to want to adjust the borders of our image. This allows us to scale our image in any direction without causing stretching or squashing by only scaling the area in the middle of the borders, and only stretching the areas on the edges and leaving the corners unchanged when we scale our image. Now let's create our inventory menu. In our player UI, let's create a new UI image, and let's add our backdrop image to the source image. And let's name it inventory menu. And when we do this, we won't see anything show up in our scene because our canvas is gigantic, because 1 square meter in the 3D view is equal to 1 pixel. So in order to work on our canvas, let's double click it to focus on it. And if we click the cube that's in our 3D gizmo that's in the top right corner of our 3D scene, it'll switch us to orthographic view, which makes working with UI stuff a lot easier. Now let's add our backdrop image to our source image, and let's adjust the pixels per unit multiplier to something like 5. This setting adjusts how big each slice, or the 9 areas made up by our border settings, is when scaling our image. Now let's adjust the size of our backdrop to whatever feels right for the size of our inventory menu. Now let's create our inventory slots. First we need an image to be our slot image. Let's add it to our UI assets folder, and like before, let's set it to a sprite. We will only be scaling this image uniformly, so we don't need to set up its borders like our backdrop. Now let's create our new UI image. Let's name it something like item panel, and let's add our panel image to the source image. Now let's make sure the raycast target checkbox is checked. This will allow us to use the area of this image as a button when we write our code. We can also alter the size of this button by adjusting the raycast padding settings here if we want to make sure parts of the element that are supposed to be invisible do not act as a button. Now let's add another UI image to our panel, and this will be our item icon UI. Let's scale it to fit inside the item slot image, and let's make sure to turn off raycast target to avoid any weirdness with our drag and drop code. Let's also disable this so we don't have to look at this white box. We are going to be toggling this on and off later in our code as we need this anyways. Now let's make our stack size element. Let's add a UI, text mesh pro text, and when we try to install this for the first time, we will get a pop-up asking to install some needed files for text mesh pro to work properly. So let's click on import TMP essentials to install the needed files. Once that's installed, we can now adjust our settings. Let's rename our text to something like stacks text. Let's set our text to a common number that would be used in a stack of items. Let's adjust our settings to something that looks good to us, and also fit it inside of our panel. Let's also open the extra settings panel so we can uncheck raycast target to, again, avoid any weirdness. We can also disable this text by default. And now that we have our elements in place, let's make this a prefab by creating a prefab folder. And inside our prefab folder, let's create a UI folder for our UI prefabs. And let's drop our item panel into our UI prefab folder. Now, to our inventory menu, we want to add a grid layout group. And we do that by first adding a UI image and removing the image component and then adding a grid layout group component. What a grid layout group does is pretty much what it sounds like. It will align all the UI elements that are parented to this element to a grid, which is what we want to create our inventory slots layout. In our grid layout group component, let's set our constraint to a fixed column count, and let's set our constraint count to something like 8. Let's also change the anchor point at the top left corner because we want our slots to grow to the right and down. Let's move our grid layout group to the top left corner of our inventory menu. And you might have noticed that after we put in our item panel, our canvas seems way too small, and that's because it is. We need to tab over to our game view to force a resize of our canvas, and when we tab back in, it will be much bigger for us to work with. And after we do this, our backdrop will obviously be too small, so let's fix that real quick. And let's also remember to name our grid layout group. Now we can test our grid layout group by taking our item panel and dropping it onto our grid layout group. And when we do this, it will snap to the center. And if we duplicate our item panel a few times, it will all snap into a grid. Now that we have our base UI set up, we can start making our scripts. The first thing we need to consider is how we want to handle the items that we're placing into our inventory. How do we want to keep track of what item we're working with? What is our item's name, and what's the maximum stack count of said item? And what icon should we use for that item? Well, a good way to keep track of this kind of information is to use an abstract class, along with many other useful features, as I go over in this video about creating Rogue-Lite style items. So what is an abstract class? Well, it's easiest to think of it as a template class that allows us to have unique code for each individual class that derives from the abstract class, but those base classes can all have generic functions that can be called, which are created in the abstract class. This will allow us to create functions that can do all sorts of things, like return our item's name, stack size, item icon, rarity, durability, anything you want, but today we'll just be doing the basics. Let's create a new folder named scripts, and inside let's create a new C# script. Let's name it item, and let's open it up. So first let's remove everything to do with mono behavior, and remove the two using systems.collections at the top. And then above our class, let's put in square brackets system.serializable. This will make this class or any class deriving from it visible in the inspector. Let's add the abstract tag to our class. Inside of our class, we are going to make a few methods that we can call, that all of our classes that derive from this base abstract class will have access to. And these methods can either have an abstract tag or a virtual tag. The difference between these tags is that an abstract tag method must be overridden when we derive from this class, where a virtual method can be ignored if wanted, because if it's not overridden, it will default to the code that we place inside this base abstract class. So let's first make a public abstract string method called giveName, and this will make sure, because it's abstract, that we have to give a unique name for each of our items. Now let's create a public virtual int method named maxStacks, and because it's a virtual method we're going to have to add a body. So let's create a body and then let's put in return 30. This return 30 will be the default that we can fall back to if we do not override this method. And then finally let's create a public virtual sprite method called giveItemImage. And this is how we are going to return a unique item icon for each of our items. And the way we'll do that is to use a handy feature called resources.load. And the way we do this is we need to create a resources folder. Any folder that you create within your Unity project called resources will become a resources folder and can be used by resources.load. And resources.load gives us access to any of the assets that we place within these resources folders. We just need to give it a directory. But you should know that any asset that you place within a resources folder must be loaded in at runtime, because Unity has to assume that any item that's in a resources folder will be used at any time. So only put things inside of a resources folder that will be used often and at random. And item icons seem like a good candidate for this. So let's create a resources folder. In our assets folder, let's create a new folder and name it resources. And inside, let's create a new folder named UI. And then inside our UI folder, let's also create another folder for item images. Let's import a few item icons. We have an icon for a wood item, an icon for a stone item, and a question mark icon. We will be using this question mark as our base return for our giveItemImage method. This will allow us to not override our giveItemImage method in our base classes, and our items will still return this question mark icon, letting us know that the item has no icon but still shows up in our inventory. And to do that, we need to remember this directory. Back in our item class, let's create the return for our giveItemImage method. Let's put return resources.load as a sprite. And then we need to pass in the directory. But because resources.load assumes we are looking in a resources folder, we only need to put as a string the remaining directory. Let's put UI, item images, no item image icon. And now whenever we make a script that derives from this item class, if we do not override our giveItemImage method, it will just use our question mark icon instead. Now that we have our item abstract class, we need to create an information holder script for our item slots. So in our scripts folder, let's create a new C# script named itemSlotInfo, and let's open it up. Now because this is an information holding script, we don't need any of the mono behavior features or any of the using declarations at the top. Let's also put above the class, in square brackets, system.serializable. This is because we will be using our item abstract class, and this will make it visible in the inspector. And the information we want to hold is first a public item named item, a public string named name, and a public int named stacks. And now we want to create a method to set that information. Let's create a public itemSlotInfo, and then let's first require an item named new item, and then an int named new stacks. And then in the body, let's put item as new item and stacks as new stacks. And then we can save our script. Now let's create our inventory script. In our scripts folder, let's right click, add a new C# script and name it inventory, and then let's open it up. So first let's make the list for our items. Let's put in square brackets serialized reference, and then let's put public list of type itemSlotInfo and name it items. And then let's put it to equals a new list of itemSlotInfo. And now we need a few game object references. And to keep our inspector tidy, let's use in brackets space to create a space in the inspector between these two references. And then in square brackets again, we can put header, and then in parentheses, inventory menu components, and this will create a header in our inspector. Now we need a few references to some game objects, so let's put first public game object inventory menu. And this will be the reference to the inventory menu we just created. And then next, let's put public game object item panel. And this will be a reference to the item panel prefab we just created. And then next, let's put public game object item panel grid, which will be our grid layout group. Now let's put space again to create another space within our inspector. And then let's put public int inventory size, and then let's default to something like 24. And this will allow us to change the size of our inventory from the inspector, or if we want to give the player a way to upgrade the size of their inventory, we could just increase the size of their inventory from here. So now we need to fill our inventory with empty slots, and we can do that pretty easily with a for loop. So let's put for int I equals 0, I is less than inventory size, I++. And then inside the body, let's put items.add, new item slot info, and then we can put null and then 0 to make this an empty slot. Now let's create a way to toggle our inventory. Also, I'm going to be using the legacy input system, but the keybinds we're going to be using are going to be pretty simple, so it should be easy to update to the new input system. So inside the update method, let's put if input.getKeyDown, keycode tab, or whatever keybind you want to use. And first let's check to see if our inventory is enabled, and we can do that with if inventory menu.activeSelf. And if it is active, we want to disable it, so let's put inventory menu setActive equals false. We can also lock our cursor to the center of the screen whenever we're not using our inventory by doing cursor.lockState equals cursor.lockMode.locked. And then let's put else, and this will be for when our inventory is not active. We will set it to active, so inventory menu.setActive equals true. And then we can unlock our cursor by cursor.lockState equals cursor.lockModeConfined. And this just means that our cursor will be locked to the inside of our game screen. And now we can save our script. Once we're back in Unity, let's add our inventory script to our player UI. In our player UI, let's collapse our other components here to make some room, and then let's hit add component, and then look up inventory and add it to our player UI. For our inventory menu component, let's just add our inventory menu that we've created in our player UI. For the item panel component, let's look for the item panel that we have in our prefabs and add it to the reference. And then for the item panel grid, let's just put our grid layout group. Now if we hit play and we tap tab, we can now see that we can toggle our inventory on and off. And we can see in our inventory script that we have 24 empty slots. For the next part of our inventory script, we're going to need the scripts we will be using on our item panels. So in our scripts folder, let's right-click create a new C# script named item panel, and then let's open it up. Once we have that open, let's remove the start and update functions since we won't be needing them. At the top, let's put in using unityengine.ui to give us access to the image component, using unityengine.eventsystems because we will be using event systems in this script, and then let's put in using tmpro to be able to adjust our text mesh pro text. For now, we just need to set up our item panels references, so the first thing we need to put in is a public inventory, let's just call it inventory, a public item slot info for our item slot that this panel will be using, a public image for our item image, and then a public text mesh pro UGUI, that's way too long, for stacks text. And then we can save our script. Now let's go to our prefabs folder and open up our item panel, and then in our item panel, let's click add component to add our item panel script, and then let's set the item image and the stacks text references. We don't need to worry about the inventory reference right now because we will be setting this as we instantiate our panels. Back in our inventory script, the first thing we need to do is at the top we need to add using system.link because we want access to its toList function. Down in our references, let's add in a new private list of item panel, and let's call it existing panels, and let's set it equal to a new list of item panels. Now, let's set up how we will update our inventory. So let's create a new method, let's put in public void, and let's name it refresh inventory. And the first thing we need to do is check how many panels we already have. And we can do that by putting in existing panels equals item panel grid dot get components and children of item panel. This will return every single item panel component that exists within our item panel grid or its children as an array. And we can convert that array to a list by putting dot to list. Now let's check if we need to create any additional panels. Let's put if existing panels.count is less than inventory size. And then inside the body, let's put in int amount to create equals inventory size minus existing panels.count to get the difference between the two amounts. Next, let's create a for loop to create our panels. Let's put in for int I equals 0. I is less than amount to create, I++. And then inside the loop, let's instantiate our panels. Let's put gameObject new panel equals instantiate item panel. And we want to parent this new panel to the item panel grid, so let's put in item panel grid.transform. And then we want to add this panel to our existing panels list, so let's put existing panels.add new panel.getComponent item panel. Now we need to loop through all of the items in our items list and update our panels with the information from our items. But first we need to keep track of how many times we have looped, so outside of our loop let's create a new local int called index and let's set it to 0. Now let's create a for each loop. Let's put for each item slot info I in items. And then inside the body, let's first name the elements of our list. If you've ever looked at a list before in the inspector, you'll notice that they are named stuff like element 0, element 1, element 2, which is not very helpful for a human. But there is a way to rename these elements. If there is a string anywhere in the information of each element, that will be used to name the element. This is the reason why we have that name variable in our item slot info. We will be using it to name our elements here. So let's put i.name equals, and then open and close quotations to start a string, plus, and then in parentheses, index plus 1. This will name our items based on where it is in our items list. Because each loop we will be increasing index by 1, this means that the first item in our list will be named 1, and then the next one will be named 2, and so on. Now let's check if our item slot isn't empty, because if it isn't empty, we can name our item slots based on the item it contains. So let's put if I.item does not equal null, I.name plus equals, open quotations, colon, space, close quotations, plus I.item.giveName. And this will add onto the name the return of our item.giveName. And then if our item slot is empty, we can put else I.name plus equals, open quotation, colon, space, hyphen, close quotation. And this will name any of our elements that are empty as its slot number plus a dash to let us know that it's empty. Now that we've named our elements, let's update our panels. Let's first get a reference to the individual panel that we're working with by putting in item panel, panel equals existing panels at our index. And because we just spent some time naming our item slot info, it should be easy to name our panels. Let's put panel.name equals I.name plus panel. Now before we go messing with a bunch of the settings, let's just check to make sure that our panel exists. So let's put if panel does not equal null. Little mistake here, we need to check that the panel exists before we change its name. If we try and change its name and we don't know it exists, it could cause a critical error. So make sure that this is inside of there. Sorry about that. Now that we've done that, let's set our panel inventory to this script. So let's put panel.inventory equals this. Next, let's set this panel's item slot to the current item slot in our loop. So let's put panel.itemSlot equals I. And now let's check if this current item slot is empty by doing if I.item does not equal null. And if it does not equal null, we want to activate our item icon image and our item stacks text. In the body, let's put panel.itemImage.gameObject.setActive equals true. And to set our item image, let's put panel.itemImage.sprite equals I.item.giveItemImage. We also want to activate our stacks text, so let's put panel.stacksText.gameObject.setActive equals true. And then let's set our stacks text by putting panel.stacksText.text equals opening close quotation marks plus I.stacks. And because we're going to be reusing these panels, we need to make sure that we turn off these objects if our slot becomes empty. So let's put else panel.itemImage.gameObject.setActive false and panel.stacksText.gameObject.setActive equals false. And then at the bottom of our loop, we need to put an index plus plus to make sure that we increase our index number by 1 every time we loop. Now in our update method, we want to refresh our inventory whenever we toggle it on. So in the section where we enable our inventory, let's call refresh inventory. Now if we go back into Unity and hit play and close and open our inventory, we can now see that our item panels are renamed to their slot number plus the word panel. And then if we look in our list, we can see that our list elements are now named their slot number and a hyphen to let us know that it's empty. Now that we have a way to refresh our inventory, we now need a way to add items to our inventory. So back in our inventory, let's create a new public method with a return type of int called addItem, and let's require an item called item and an int called amount. And first we want to check if any slots in our inventory contain this item and have open slots. So let's do for each item slot info I in items, and then let's check if I.item does not equal null. And if it isn't, let's compare the name. Let's put if I.item.giveName equals the item that we passed in. And now that we know that this item slot contains the item that we are trying to fill our inventory with, let's check how much we can add to this slot. And to do that, let's first check if our amount is greater than the remainder in this slot. So let's check if amount is greater than I.item.maxstacks minus I.stacks. And if it is, let's reduce our amount by that remainder. And then let's set this slot stacks to max. And if our amount variable is not greater than the remainder, let's just increase I.stacks by amount. And because that means we filled our inventory with the amount that we've passed into this method, we need to exit this method. So let's first refresh our inventory if it's open. So let's check if inventory menu.activeSelf, and then let's call refresh inventory. And to exit out of our method, we need to return an integer because our method is a return type event. And the reason our method is a return type event is because we want to be able to return the amount that we weren't able to add to our inventory. And because we were able to add everything to our inventory, we need to return 0. And if we complete this for each loop, that means there is either no slots in our inventory that had the same item, or there was no space. So now we need to go through the empty spaces and fill what we can with our remaining amount. So now let's again put for each item slot info I in items. And then let's check if this slot is empty, so let's put if I.item equals null. And if it is empty, let's check if amount is greater than item.maxstacks. And if our amount is greater, we can just fill the slot. So let's put I.item equals item, I.stacks equals item.maxstacks, and amount minus equals item.maxstacks. And if our amount is not greater than maxstacks, we can just fill this last slot with the remainder. So let's put I.item equals item, I.stacks equals amount, and if our inventory is active, let's refresh our inventory, and then let's again return 0. And at this point, we will only reach this far down into the method if our amount is greater than 0. So that means our inventory is full and we need to return the amount that we weren't able to put into the inventory. So let's first call a debug message. Let's put debug.log, and then let's put no space in inventory for, space, plus item.giveName. And then let's again refresh our inventory. In case we have filled some slots, we just haven't exhausted our amount variable. And then let's return amount. And before we close our script here, let's create a very small helper method. Let's put public void clear slot, and let's pass in an item slot info. And let's just call it slot. And then inside, let's just put slot.item equals null and slot.stacks equals 0. And then we can use this to clear our slots easily. Now that we have all of that done, let's finally create a bespoke item. In our scripts folder, let's right-click, create a new C# script, and name it wood item. Inside the script, let's first remove the start and update functions, and let's change mono behavior over to our item abstract class. And let's also remove the two using system collections declarations at the top. Now our class name has the annoying red squiggly line, and this is because we must override the giveName method from our abstract class, because it is an abstract method. So let's do that right quick. Let's put public override string giveName, and then in the body let's return wood. Let's also change the max stacks. Let's public override int max stacks, and then let's return something like 10. And then let's override our giveSprite image, so let's public override sprite giveItemImage, and change the return to return resources.load as a sprite, and then we need to check what directory we want. Back in Unity, let's check our resources item images folder and look at our wood icon and check its directory. And then let's return its directory. And then let's save our script. Then let's move over to our inventory script. And later on we will be making a proper way to pick up items, but now in the start function, let's create a little area for testing purposes. Let's add a comment saying that this area is just for testing purposes, so we remember to remove it later. And then let's call add item. Let's add a new wood item, and then let's add 40 to our inventory. And now we can save, go back into Unity and hit play, and we can see our items being added to our inventory. Now we have an inventory system and a way to add items. But before we can create our drag and drop system, we need to set up one last key UI element, the mouse. So let's add a new UI image, and for this is what we would want our mouse to look like. If you don't have a graphic yet for a mouse, don't worry. There's a good stand-in Unity's built-in images. So let's click the little target button, and on our source image, let's search for knob. This will serve as a dot-style mouse pointer for us. Let's also make sure that we turn off raycast target for this image. And this one is very important because this image will be following our mouse wherever it goes. And if this is left checked, we won't be able to click on any other element as this image would always be in the way. And now for our held item element. This will actually be very easy since we already basically have this set up with our item panel we created earlier. So let's pull an item panel out of our UI prefab folder and attach it to our mouse element. Let's also remember to disable the item panel image attached to our mouse as a raycast target. Let's place it somewhere close to our mouse but off to the side. And then for this element, let's go in and enable our item icon image and our stacks text, but then disable the item panel itself. So we only have to toggle the panel itself on and off. Now let's create the script for our mouse. In our scripts folder, let's create a new C# script and name it mouse, and then let's open it up. So first we're going to need access to the UI and the TM Pro declaration, so let's add them at the top. And then now we need some references. First we're going to need a public game object of mouse item UI. Next we're going to need a reference to the image for our mouse cursor, so public image mouse cursor. We're also going to need a reference to the item slot that we are currently holding, so we're going to need a public item slot info, and let's just name it item slot. Next we're also going to need a reference to our item icon, so let's put in a public image item image. And finally we need a reference to our stacks text, so let's put in public text mesh pro UGUI stacks text. Now down in our update, the first thing we want to do is make sure that our mouse element here is always at the mouse's position, which is actually pretty easy. All we have to do is change our transform.position equal to input.mousePosition. Now let's check if our cursor is locked, and if it is, let's disable our UI. So let's check if cursor lock state equals cursor lock mode locked. Let's set mouse cursor.enabled equals false, and then for the item slot image attached to our mouse, let's put mouse item UI.setActive false. And then we can use else for when our cursor is not locked, and if it is not locked, we can set mouse cursor.enabled equals to true. And then we only want to enable our item panel if our item slot has an item in it. So then let's check if item slot that item does not equal null, and if it doesn't, let's set our mouse item UI.setActive to true. And then when our item is null, we want to disable it, so let's put else mouse item UI.setActive to false. Now before we save our script, let's create a few helper methods. Let's first make a public void set UI, and then inside let's set our stacks text.text equals to open and close quotations plus item slot.stacks, and then our item image.sprite equals item slot.item.giveItemImage. And then let's create another method to empty our slot. So let's create public void empty slot, and then let's put item slot equals a new item slot info of null and 0. Now back in Unity, let's add our script and set our references. And then if we go in the game, we can see our mouse element following our mouse position. Now back in our inventory script, let's add a reference to our mouse. And down in our update function, we want to clear our mouse's item panel whenever we turn our inventory off. Let's also add the same line to the bottom of our refresh inventory method, since we will only be calling this method to finalize a change to our inventory, so we want a clean mouse. And then let's add our mouse to our mouse reference in our inventory script. Now to finally set up our drag and drop system, back in our item panel script, let's create a new method called onClick. So first, to avoid any errors, let's make sure that our inventory reference isn't null. So let's go if inventory does not equal null. And this script is going to take a bit of reference diving, so to shave down on that a little bit, up in our references, let's make a new private mouse reference and just name it mouse. And then let's set our mouse reference to the one that's in our inventory. So mouse equals inventory.mouse. Now we want to handle what happens when we pick up an item, so let's put if mouse.itemSlot.item equals null. And to make this a bit more readable and easier to adjust if needed, let's break up our tasks into individual functions. So let's create a new method called pickUpItem, and then inside let's set the mouse's item slot to this item slot, and then let's call our mouse.setUI method. Back in our onClick method, let's first check to make sure that there is an item in this slot to pick up, and then let's call our pickUpItem function. It would also be nice to have a little bit of a fade effect on our panels whenever we pick up an item. So let's create a new function called fadeOut, and inside let's use a handy little feature called called crossfade alpha. So let's call itemImage.crossfade alpha. And first we have to put in the alpha that we want to set this image to, so let's go with something like 0.3. Next we need to put in the amount of time it takes for our panel to fade out. So let's go with something really small like 0.05. And then we need to put in if we want this effect to ignore the time.scale variable. And we do, so let's put in true. Now back down in our onClick method, let's also call our fade out function whenever we pick up an item. Now we want to handle what happens when we click on a panel, but we already have an item in our mouse. So let's use else. And then let's first handle whatever happens whenever we pick up an item. And then we drop it right back down into the same slot we picked it up from. And to do this, let's first check if our item slot is the same as our mouse item slot, and if it is, let's just refresh our inventory, because this will set our inventory to the state it was in before we picked up the item. Now let's handle what happens when we click on an empty slot. So let's do else if item slot.item equals null, and then we want to create a new function for dropping an item. So let's create a new method called dropItem, and in here we just want to transfer the information that's in our mouse to this slot. So let's set our item slot item equal to our mouse item slot item, our item slot stacks equal to our mouse item slot stacks, and then we want to clear our mouse's item slot, so let's call inventory.clearSlot mouse.item slot. Now back down in our onClick method, let's call our dropItem function, and then let's refresh our inventory. Now let's handle what happens when we click on an item slot that already has an item but of a different type, so we would need to swap the item. So let's put else if itemslot.item.giveName does not equal mouse itemslot.item.giveName. And if it doesn't, let's create a new function for swapping items. So let's create a new method called swapItem, and let's require two item slot infos, one called slot A and another called slot B. So to swap an item, we need to transfer the information from slot A to slot B, and then vice versa. But if we copy the info from slot A to slot B, we have now lost the information we need to transfer back to slot A. So before we swap our slots, we first need to hold on to the information of one of our slots in a local variable. So let's create a local item slot info of temp item, and let's make it equal to a new item slot info that is of slot A's item and slot A's stacks. Now that we have our information stored, we can now safely swap our items. So let's set slot A's item to slot B's item, slot A's stacks to slot B stacks, and then slot B's item to our temporary item, and slot B stacks to our temporary stacks. And we have now swapped our items. And then back down in our onClick method, let's now call swapItem, and then pass in our item slot and our mouse's item slot, and then let's refresh our inventory. And now to implement our drag and drop functionality. This will actually be pretty easy, as Unity handles most of the heavy lifting for us already. To start, we need to add a few tags to our item panel class in order to use the event systems. So after model behavior, let's add iPointerEnter handler, iPointerDown handler, iPointerUp handler, iDrag handler, and iDrop handler. In our variables section, let's also add a private bool named click. We will be using this to keep track of the clicking and holding of our panels. Now we need to add the methods relating to the event system tags we just placed. So let's first add a public void on pointerEnter, and let's pass in an event data, so let's put in pointer event data as event data. And this just points to the event data object that is in our scene. And the only thing we will be doing with this method is setting our eventData.pointerPress equal to this game object. Because our item panel script here is obviously going to be on every single one of our panels, we need to make sure that the event data knows specifically which game object that we're trying to interact with. So this makes sure that whenever we hover over one of those panels, it is automatically added as the target game object. Next we want to add our onPointerDown method, and in here all we need to do is set our click to true. And this is how we will be keeping track of clicking and holding. And then let's add our onPointerUp, and in here all we need to check for is if click is true, and if it is, let's call our onClick method and set click to false. And then for our onDrop method, we just need to call onClick and set click to false. And then finally our onDrag. In here we just need to copy what we did in our onPointerUp method. And then if we hop in game, we can now see our drag and drop system in action. Now our drag and drop system should be working fine, but if we pick up an item and place it back down into the slot we picked it up from, our crossfade alpha is persisting. So back in our inventory script, where we check if an item is null or not whenever we activate its panels, let's crossfade the alpha back up to 1. And that should solve our fade out issue. But we don't have a second item to try out our swapping. So let's create a new item real quick. To save us a bit of time, let's just copy our wood item here. Let's rename it to stone item. Then let's open it up and rename the class to stone item. And then let's change the return name to stone. Let's change its max stacks over to something like 5. And then let's change our resources.loadSprite over to our stone icon. Now back in our inventory script, in the start function where we were adding some test items, let's put in a new add item, new stone item, and let's set it to something like 20. And because we set our stack size to 5, this should give us 4 stacks of stone. And now if we hop back into game, we can test out our item swapping. Now to flesh out our inventory system further, we need to handle item splitting. And to do that, we need to modify our mouse script. So back in our mouse script, let's add a couple of references to the top. First, let's add a public item panel called source item panel, and a public int called split size. So how do we want to handle our splitting? Well, it would be nice to, instead of having a dialog pop up where we have to choose how much we want to split by before we begin the split, or just also just directly splitting it in half always, it would be nice if we could use our scroll wheel in order to dynamically change the amount we're splitting our stacks by as we're holding the item. And to do that, down in our update function, let's first check if our item slot is not null, and if it's not, let's first check for an input from our mouse scroll wheel. So let's put if input.getAxis, and then in quotations mouse scroll wheel, is greater than 0, and split size is less than item slot.stacks, because we don't want to try and split our item for more than it actually contains. We can then increase our split size by 1, so split size plus plus. And now we want to check the opposite, so if input.getAxis mouse scroll wheel is less than 0, and split size is greater than 1 because we don't want to go below 1, we can then reduce our split size by 1, so split size minus minus. And then we can set our stacks text.text equal to split size. Now we need to show that difference to our source item panel. But before we do that, let's first check if we are actually splitting the item, so let's check if split size equals item slot.stacks. And if it is, meaning we aren't splitting the item at all, let's just turn off the stacks text of our source item panel. So let's put source item panel stacks text game object set active equals false. And then we can use else for the opposite, so let's put else. And in here we would first want to re-enable the stacks text of our source item panel, and then we would want to set its text to the difference, and we can do that with source item panel stacks text equals open and close quotation marks, plus, and then in parentheses, item slot.stacks minus split size, and this will give us the difference. Then down in our setUI method, let's instead of setting our stacks text.text equal to item slot.stacks, let's set it to our split size. Now back in our item panel script, let's update our pickup item and our drop item methods. In our pickup item, let's set our mouse's source item panel equal to this item panel. We can also easily add a stack halving feature by putting in if input.getKeyDown left shift, or whatever keybind you would like for splitting items, and our item slot.stacks is greater than 1, mouse split size equals item slot.stacks divided by 2. And because our item slot.stacks is an integer, this will always be floored to the nearest integer, and this will split our stack in half. And then we can use else to just set our mouse split size equal to item slot.stacks. And then in our drop item method, after we set our item slot to our mouse's item slot, let's check if mouse.splitSize is less than mouse item slot stacks. And if it is, let's set our item slot.stacks equal to mouse split size. Let's reduce our mouse's item slot by that split size. So let's do mouse item slot stacks minus equals mouse split size. And then let's call mouse empty slot. And then we can use else and wrap it around our previous code. Now if we hop back in the game and pick up an item, we can use our scroll wheel to start splitting that item. Or we can use our shift key to just split the item in half directly. But now that we have a way to split our items, we now need a way to stack our items. So let's hop back into our item panel script. So let's make a new method called stackItem. Let's pass in an item slot info named source, another item slot info named destination, and an int for amount. Now let's create a local int called slotsAvailable to check how much space we have in this slot, and let's set it equal to destination.item.maxstacks minus destination.stacks to give us our difference. And now we can use this to check if slots available equals 0, we can then return to exit out of this method early because we have no space for the item. Now let's first check if our amount is greater than the amount of space in this slot, so let's check if amount is greater than slots available. And if it is, let's reduce our source stacks by the slots available, and then max out the stacks of our destination slot. And then we can handle what happens when our amount is equal to or less than slots available, so let's check if amount is less than or equal to slots available. And if it is, let's set our destination stacks to plus equal amount. And then let's check if source.stacks equals amount, we then want to clear that slot. So let's call inventory clear slot source. And then we can use else to handle when this is not true, like if we were trying to stack an item that has been split, let's use else source.stacks minus equals amount. And now we can set this up in our onClick method. In our else if line, we already have a stop for if the item is null, and if the item does not have the same name. So because of this, all we need to do is ask else if item slot.stacks is less than item slot.item maxstacks. And if it is, we can call our stack item, and set the source to mouse.item slot, set the destination to this item slot, and then we can just use the mouse split size as the amount. And then we can call refresh inventory. And now if we hop back in the game, we can now split our items and stack them. It would also be nice if we could right-click to drop our items as a quick bit of polish. Let's just go back to our inventory script, and inside our update, let's put if input.getKeyDown, keycode mouse1, and mouse item slot.item does not equal null. Let's just refresh our inventory, because this will reset us back to the state it was in before we picked up the item. And now we have a working inventory system, but we're missing an important feature, the ability to pick up items. Our items are all based off our abstract class we created earlier, but this has a problem that we need to work around. We cannot drop an abstract class or a script deriving from an abstract class into a script reference like we can with a prefab or a component, so we need to create our item references. Since we have our inventory script here, it would be nice if our inventory had a reference to all of our items in our project, so it knew what to add when we call our addItem method, and a good way to handle this is with a dictionary. So what is a dictionary? Well, it's very similar to a list, but with each element element, there's also a pointer to find a specific entry in the dictionary. This is done with a key. A dictionary requires both a key and a value. The value is the information we want access to, and the key is the way to quickly find that information. So first in our inventory script, let's create a new dictionary that is a key of string and a value of item. Let's name it something like all items dictionary, and let's set it to a new dictionary of string and item. And now for getting all of the items in our project, it's actually just going to be one method and one line of code, but it's a very long line of code. So let's create an IEnumerable that is a type of item, and let's call it getAllItems. And then in the body, let's return system.appDomain, current domain, getAssemblies, .selectMany, assembly, lambda, that's what that equal sign and a greater than means, it's a lambda expression, assembly.getItems, .where, type, lambda type is subclass of type of item, .select, type, lambda, system.activator.createInstance type as item. And this will go through our entire project and find all of our scripts that are a subtype of item, and will return as an array. And because it returns as an array, we can convert it to a list, which will make it easier for us to turn it into a dictionary. And to build our dictionary, let's first go up to our start function, and let's create a local list variable that is a type of item, and let's call it allItems, and let's set it equal to getAllItems.toList. And this will convert all of the items that return as an array to a list. And now we can loop through that list. So let's do for each item I in allItems. And first, let's check to make sure that our dictionary does not already contain this item's name. So let's do if, allItems in dictionary.contains key, and then I.giveName. And if it doesn't, let's add it to the dictionary with allItemsDictionary.add, and then for its key, let's use I.giveName, and for its value, let's just use I. And then we can use else to handle what happens if our dictionary does already contain that name. And if it does, we can make it easy for us to make sure that all of our items have a unique name. And to do that, we can use the debug.log, open and close quotations, plus I, plus already exists in dictionary, and it shares a name with, plus all items in dictionary, and then in square brackets, I.giveName. And this will log both the item that we are trying to add to the dictionary that has the same name, and the name that already exists in the dictionary that has the same name. And this will make it easy for us to find items that we have accidentally gave the same name to. Since a lot of our inventory code works off of our items having unique names, this should help us out a lot. And to help us understand what is in our dictionary, let's create a little debug log that tells us exactly what is in our dictionary. And we can do that by first creating a local string variable. Let's name it something like items in dictionary, and let's set it equal to items in dictionary : space. And then down in our for each loop, whenever we add an item, let's put items in dictionary plus equals, and then a comma with a space, plus I.giveName. And then below our loop, let's put items in dictionary plus equals period to finish our log string. And then we can do debug.log items in dictionary, and this will give us a log of all the items in our dictionary. And now we can update our add item method. Let's first change over that item that we're passing in over to a string called item name. And inside at the top, let's first create a local item called item, and let's set it equal to null. And then let's check our dictionary for the item name. So let's put all items in dictionary dot try get value item name, and we need to out this to an item, so let's out it to our item local variable. And now let's make sure that we actually have found an item, and if we haven't, let's exit the method. So let's do if item equals null, debug.log could not find item in dictionary to add to inventory, and let's return the amount. And then we can update our two test add items in our start function over to their string names. And if we hop back in the game, we should see that our items are still being added to our inventory, and our console will list the items that have been added to our dictionary. And now with all that done, it should be super easy for us to make an item pickup script. In our scripts folder, let's create a new C# script and name it item pickup, and let's open it up. Let's first remove the start and update methods since we don't need them, and then let's put in a public string of item to drop and a public int of amount, and let's set its default equal to 1. And now let's make our pickup method. Let's make a public void pickup item that requires an inventory. And now, because the way we created our add item method returns the amount that could not be placed into the inventory, we can use that return to set our amount in our item pickup script. So let's set amount equal to inventory.addItem, and then pass in item to drop and the amount. Then we can check if amount is less than 1, and if it is, we can destroy this game object. And now if we want to create a simple walkover script, we can call onTriggerEnter, check for the tag that we set on our player, find its inventory. We can do that pretty easily by doing getComponent in children for inventory, and then check if we found our component, and if we have, call our pickup item. And now that we have all that set up, all we have to do to create an item is make a game object, put on a sphere collider, and remember to turn off the trigger. Give it a rigid body to make sure that the onTriggerEnter works and turn off gravity, and put our item pickup script on it. Give it the name of the item we want to pick up and the amount. And then we can start picking up items. These two items here are wood items, and this number shown is the amount that's inside the item, and when we walk over one, it almost fills up our inventory, and because we absorbed all the items inside that item pickup script, it deletes the game object. But when we go to pick up the second item, it fills our inventory but does not delete the item because we have not absorbed all of its contents. And because our add item method returns the amount that was not able to be placed into our inventory, the amount inside of our item pickup script is updated appropriately. And now for our item dropping functionality. We are again going to be using resources.load, so we need to create a new folder. So let's create a new folder called pickup items. Back in our item abstract class, let's create a new method to give the item that we want to drop for each item. So let's create a new method. Let's make a public virtual with a return type of game object. Let's call it drop object, and let's have it return resources.load as a game object, pick up items, and because this is our base abstract class, let's have it return a default item. We will actually be making this item in just a moment, but first we need to work around a problem. We want our items that we drop to have physics, but if we add a new non-trigger collider to our object, our player will bump into the side of our object. So we need to set up our item so it has physics that does not interact with the player, but still allows the player to collect the item. To do this, we need to update our item pickup script. We are going to be nesting our item pickup script into a child object, so we need to update our item pickup script to destroy the base root object and not the child object that it's sitting in. And to do this, it's actually pretty easy. We just need to change this.game object over to this transform root game object. Now for our pickup item, we need to think about how our physics layers are organized. Our player wouldn't normally be a camera like we have in our scene here. Our camera would normally be attached to another game object, and that parent object would either be on the default layer or a layer that we have created, named something like player. The walkable surfaces of our game would also usually be on their own layer, named something like floor or ground. Because of this, we could create a new physics layer that would only react to the walkable surfaces of our game, but would not react or affect our player. To do this, let's create a new physics layer for our pickup items. So let's add a sphere to our scene and name it default item. This will be our fallback item object, and then let's give it a rigid body. Set the mass to something like 5 and the drag to 1 to make our item physics a little bit less floaty. And for this object, I'm going to lock the rotation in all axis. And this is just a preference. If you want your items to be able to roll around, just leave these unlocked. And let's give it a sphere collider that is not a trigger, and let's increase its size to something like 2. The size and shape of this collider can be whatever you want if you'd like to have your items behave differently. Now for its layer, let's click the drop down and go to add new layer. Let's create a new layer, named something like only collide with ground, and let's set our items layer to this new layer. Now, to make this layer only interact with the ground layer, in the top left of Unity, let's click Edit, Project Settings, and in the Physics tab, let's scroll down to the triangle of physics interactions. Under our new Only Collide with Ground layer, let's uncheck every layer other than ground, and now this layer will only interact with the ground layer. Now to our default item, let's set up our item pickup script. Let's right click and add an empty to our item, and let's name it something like Trigger, and let's switch its layer back to the default layer. Let's add a rigid body so our on-trigger enter works properly, but turn off gravity and freeze its position and rotation in all axis so it stays locked to our parent object. Now let's add a new sphere collider that is a trigger and increase its size. And finally, let's add our item pickup script. We can set its default name and amount here, but we'll be changing this in our code as we drop our items. And then let's place it into our pickup items resources folder. And now to create our drop item functionality, back in our inventory script, let's create a new method called drop item, and let's pass in a string named item name. So let's first find our item in our dictionary like we did at the beginning of our add item method. And to do that, let's just copy what we have in our add item method. All we need to do is change the debug.log and remove the amount on our return. Since this method is a void, meaning it doesn't return anything, we can just use return to exit out of the method. Now let's get our camera's transform with transform.camTransform equals camera.main.transform. And we're going to be using this for the direction that we throw our items. And now to spawn our object, let's do gameObject drop item equals instantiate. And for the item, let's use item.dropObject. For the position, let's use this.transform.position plus a new vector3 of 0, 1.8, and 0. This is just to raise it up off the ground a little bit, because often the origin of our player object is the floor, and spawning it directly on the floor will often cause it to fall through the floor. And then let's put plus camTransform.forward. And this will push our spawn location 1 meter out in the direction our camera is facing. You can also multiply this value to increase or decrease the projection distance, but be careful because you can again project it into the floor. And for its rotation, let's just set it to 0 with quaternion.Euler vector3 0. And now for our throwing action, let's add a little bit of a velocity to our rigid body. So let's first get the rigid body with rigid body RB equals dropped_item.getComponent rigid body. Now let's check to make sure that we've actually found something, and if we have, let's set RB.velocity equal to camTransform.forward times 25. And this will give our item a velocity of 25 meters a second in the direction of our camera. And now let's set our item pickup script's information, so let's do item pickup IP equals dropped_item.getComponent in children item pickup. And then let's check to make sure that we found something, and if we have, let's set ip.item_to_drop equal item name, ip.amount equal mouse.splitSize, and then finally mouse item slot.stacks minus equals mouse split size. Then let's check if mouse item slot stacks is less than 1, because if it is, that means our slot is empty, so we need to call clear slot on mouse.item slot. And then let's clear our mouse's item slot reference with mouse.empty slot, and then let's refresh our inventory. And to call this, we're going to need access to the event system, so at the top let's put using.unityengine.eventsystems. We're going to be using this to check if we're hovering over the UI or not, so we can drop our items into our scene. And to do that, in our update function, let's check if input.getKeyDown, keycode mouse 0, and our mouse item slot item does not equal null, and not_event_system.current.is pointer over game object, and this will check if our pointer is over a UI element or not. And then finally let's call drop item, and then let's pass in our mouse's items give name. And that's it. We now have a drag and drop inventory where we can pick up, split and stack, and drop items. I hope you enjoyed the video. Remember to like, comment, and subscribe, and I will see you in the next video. Later.